Hi, I'm going to show you a technique for adding vectors. So let's say I have this vector A, which has a length of 8 and is 20 degrees clockwise from the positive y-axis. And let's say that I have vector B, which has a length of 6 and is 50 degrees clockwise from the negative x-axis. So first thing I do when I'm confronted with a vector addition problem is I convert any angles to being counterclockwise from the positive x-axis. So let's do that first. So let's redefine A in terms of an angle that is counterclockwise from positive x. So magnitude is still 8, and then I want to know what this angle is here, counterclockwise from positive x. That'll make my trig functions easier. That angle would be 90 minus 20, giving me 70 degrees. And likewise, I can determine the magnitude and direction of B. The magnitude is already given as a length of 6, and then it's 50 degrees clockwise from the negative x-axis, so that makes it 130 degrees, which is 180 minus 50 degrees, 130 degrees counterclockwise from positive x. That's sort of the conventional way that we measure angles in physics class. So I want to add these vectors. The way I'm going to do that, let's first define the problem I'm doing. So vector C will be A plus B, and we're going to try to find out what C is. So the next step is to use the magnitudes and directions in order to find the x and y components. So I want to find a x component, and that will be A times cosine theta. Okay, so the reason that I specified counterclockwise from positive x is that I know that the cosine function is associated with the x components, and the sine function will be associated with the y components. So at this point it becomes very mechanical. Don't really have to think about it at all. Just plug in the numbers into the formula. So 8 times cosine of 20 degrees. I throw that into my calculator and I get 2.74. Okay, no units here. This is just an abstract vector addition. Okay, and then similarly with the y component, I use the magnitude and direction, but this time I use the sine function. And so using the same data, 8, and just switching the trig function to sine, and I get an answer of 7.52. Okay, and then I can follow the same procedure for vector B. So vector B is its x component will be its magnitude times cosine of its angle. So I use 6 and 130. 6 times cosine of 130. I throw that into my calculator and it tells me that it's minus 3.86. And then to determine the y component, it will be the magnitude times the sine of its angle. So 6 times sine of 130. And notice this, that the trig functions are getting us in the right quadrant. We don't have to, I mean, it's good to check, but we really don't have to if we have confidence in these formulas. So 4.60. Okay, so I've got x and y components. Those are easy to add. So this problem is really two problems. We'll add the x components and we'll add the y components. So C sub x will be a x component plus b x component. So I take 2.74 and I add negative 3.86 and I get an answer of minus 1.12. And similarly, I will add the y components, y component of A, y component of B, and I take 7.52, add it to 4.60, and I get 12.12. Okay, and so I'm basically done. I have the x and y components. I have added these vectors. Oftentimes we want to report this as a magnitude and direction, so we'll go ahead and convert that back to a vector that looks like this. So C, the length of this vector described as having an x component of minus 1.12, a y component of 12.12, would be square root of the sum of the squares. So minus 1.12. Be sure in your calculator that you don't put the minus side outside the parentheses, otherwise you'll get a wrong answer. So square root of the sum of the squares, giving me 12.2. And then for the angle, we take the inverse tangent of the y component over the x component. So the y component is 12.12 divided by the x component of minus 1.12. I throw that into my calculator and I get minus 85 degrees. Okay, but that isn't right because the x component is negative. This is actually a step in this process where you have to think about it a little bit, and we're getting a vector that points down and to the right instead of up and to the left. So we have to add 180 degrees to this, and I get an answer of 95 degrees. Okay, so that's our correct direction. Okay, so we'll go ahead and write down what C is in terms of magnitude and direction. So I have an answer of 12.2 and 95 degrees measured counterclockwise from positive x. Okay, so that's it. Thanks for watching.